Bilang ah.
Continue.
Bismillahirrahmanirrahim. Assalamualaikum and good morning, everyone. Can you hear me?
Morning, sir. Yes.
Okay, thank you very much. So, for section 7 and 8, we continue our lecture. So, I repeat again. Last 2 days, I discussed about the root locus plot. Okay. So, I refer to page 10 where we are given transfer function. Okay. Or the model k over s square plus 10s plus k. And then we vary the value of gain k. Okay. And then we insert inside this model. And then you find the roots. Okay. The roots of the characteristic equations. Okay. Begin with 0, 5, 10, 25, 20, 25. Okay. And then continue to 30, 40 until 50. Then we get the data. We plot on the S-plane. So this is the S-plane where imaginary exists versus real exists. Okay. Which is this one. And then this plot, this point, the blue point will be connected together. Okay. By the red lines. Okay. And we get the root locus, which is the red color. Okay. And this root locus begin from -10, -8, -6. Then it met at this point, which is -5. It's known as a breakaway point. Okay. Then this the first locus will go to the until infinity, and the second locus will begin from 0. Okay. Then met at -5 breakaway point, and ended at infinity as well. Okay. So we verify the plot using
Kak Dodi masuk dah
dah.
aku masuk kat ni.
Masuklah. Okay. So we plot it using the transfer function. Okay. And then we type this code, okay, as equal to TF apostrophe S apostrophe. Then we write the the transfer function by defining k equal to 1. And then we call the function root locus g and then grid. Okay. Then we get to the locus as shown here. This is your -10. And this is your origin at zeros. And this is the breakaway point. Okay. So I repeat again. Okay. So this is the imaginary axis. And this is the real axis. Okay. Please remember. And then this line, the straight line from the origin is the zeta line or damping ratio line. And the circle line in the grid is the omega n line or undamped natural frequency. Okay, so for j omega axis, okay, actually it is j omega d. Okay, and omega d is equal to omega n 1 minus zeta squared. So what is the difference between omega d and omega n? It is both are frequency. Okay, both are the frequency. But omega n is undamped natural frequency and omega d is the damped natural frequency. Okay, and this damped natural frequency is equal to omega n multiplied by square root 1 minus zeta squared. And for the real axis, which is this one, sigma, is equal to minus zeta omega n, meaning that uh, this axis, okay, is the real axis, which is equal to minus zeta omega n. Okay, as I shown here. Okay, so this is your minus pi. This is your real axis. This is the imaginary axis. Okay. And the grid inside the root locus plot is zeta line. And the circle is omega n. Okay. So in control system design, our area of concern is this one, this quadrant. Okay. So you must make sure that all the controller that you design in this course is bare or in this quadrant. Okay. And this quadrant, the range of zeta is between 0 and 1. Okay. And this one is known as underdamped zone. Okay. Underdamped zone, meaning that this is where the system will work in good response, stable, okay, and no issues. Okay, so make sure that the controller will control the model in such a way that it works in the underdamped region. Okay. Okay, guys. Understood? Hello?
Understood.
Do not sleep in my class. So again, I would like to remind you, if this quadrant, blue quadrant, is between 0 and 1, so this axis, okay, this zeta is equal to 0, and this axis, zeta equal to 1, okay? So the border of the this quadrant is begin with zeta damping ratio equal to 0 and goes down here where the damping ratio is equal to 1. So you must make sure that the zeta is in this quadrant. The best zeta is equal to 0.707. Okay, that is the best or the targeted damping ratio value for the controller design. Right, guys, we continue to the next slide, which is slide number 15. As you know that general response relationship for the second order system, it begin with this zeta known as damping ratio. Okay, so if damping ratio equal to 0, okay, equal to 0, so the poles are located on the imaginary axis. Okay, as we shown here, right? And the outcome, the response, the output response is here, oscillations, okay, from 0 towards infinity, which is not very good, okay? So we call it as under, okay? So oscillation, we go up, go down, go up, go down, which is not very good. And then the best that we targeted is between 0 and 1. This one, we call it as under dam, okay? And under dam will give you the location of poles as shown here. So what can we say that it is known as complex conjugate poles. Okay, one at the positive side, the other one at the negative side. And this is what I mentioned just now, omega n multiplied by square root 1 minus zeta square, which is equal to j omega d. Please remember this formula. Okay, please remember this formula. And this one is the axis of the real axis, which is known as minus zeta omega n, okay? The real axis value. The third one is zeta equal to 1, okay? This one is known as a critical dam. Critical dam, the response name, critical dam, okay? So for critical dam, the nature of the poles is we call it as overlap. Okay, overlap poles. Okay, in Bahasa Melayu is bertindih. In English, we call it as overlap poles, where the value of the poles is the same. Okay, and located on the real axis. Okay, or overlap poles, so some books write it as a repeated pole, also same. Okay, repeated poles. And the response is shown as here. Okay, less better than under dam. Then the other one is zeta greater than 1. Okay, this is known as over dam response. When it's over dam response, the nature of the poles of the system is real and different on the real axis. Okay, as shown here. And this is the response. So we already discussed this category. So I would like to ask some questions. Okay, whether you remember or not. Mana I remember. Okay. We already know that zeta equal to 0, zeta equal to 1, zeta greater than 1, and zeta between 0 and 1. There is another one, which is zeta less than 0. Okay, so what is this category? Can I ask question? Aiza? Aiza Sofiana Hussein. Hello, Aiza. Are you there? Tak datang. Tak datang. Chiu Yong Jun? Chiu.
Yes, doctor.
What is zeta less than 0? This is category number 5.
Zeta less than 0.
Oh,
You mean the under
again,
them
zeta 0 is undammed.
undammed.
Zeta 1 critical dam. Greater than 1 over dam. Then between 0 and 1 is under dam. So when the question said what is the name of zeta less than 0?
Under them.
Under dam is already there. Yeah. Go Yong Sio. Go Yong Hao.
Yes, doctor.
Hmm.
I think it is a unstable system.
Unstable system. Very near to my answer. Izhar.
Yes, doctor. Can you hear me?
Hmm.
How about
Yeah.
negative damping?
Negative dam. Okay. So negative dam. So the location of the poles. Location of the poles. Yong. Yong tak datang. Nurul Najiha.
Ya, dokter.
Location of poles for negative dam.
Negative imaginary.
Ayo yo. Kau cakap apa yang kau merepek ni? Ali Imran.
Sekejap eh.
Location of the poles for negative dam. Tak tahu.
No idea, no idea. Sorry.
Amira Suraya.
Yes, doctor.
Hmm.
At the positive side.
At the positive side, correct. So at the positive side. Very good. And then what is the response of the output? Aiza. Aiza tak ada. Chua. Chua Hua Li.
Increase to infinity.
Apa benda tu? Tak tahu. Sophia, what is the response or negative dam? Can you see my drawing? Can you see my drawing?
Yes.
Comment?
Amplitude dia
Sophia?
increase.
Hmm?
Amplitude dia increase.
Amplitude increase without limit when time towards infinity, becoming bigger and bigger lah. So meaning that it's not stable. Okay, not stable. Right. So we move to the next slide, which is slide number 16. Okay. So in slide number 16, we are referring to the drawing, which is over here. This one, guys. Okay. This drawing. Let me delete my handwriting. Okay. So I referring to this figure. Okay. Or maybe I just wrote it here. Okay. Okay. Can you see, guys? Can you see, guys? Okay.
Yes, Doctor.
So the root locus here, when k less than 25, the gain, this k is the gain. When the gain is less than 25, the poles are real. Okay, real. Okay, the nature of the poles is real and over them. Right? I.e. zeta greater than 1. But if the k is equal to 25, the poles are real and multiple. Okay, overlap lah. Overlap. Okay, in this case is at -5 lah. Okay, less than -5. But if k is greater than 25, the nature of the poles is complex poles. Okay, under them, which is between 0 and 1. Okay, meaning that this part lah and this part. Okay, so we can see that for the underdamped system, regardless of the gain value, the real parts are always the same. Okay, real parts always the same, which is -5. And then the imaginary value is different. Okay, because one going up and one going down. So the settling time remains the same. Okay, so for your information, TS settling times, the formula is 4 divided by zeta omega n. Okay, so it is what do you call that? This is the real part. Real part of S-plane. Okay, real part of S-plane. So since the root locus never cross to the right half plane, which is on this side, okay, so this is P, this is plane, half plane. The system is always stable for all values of K. Okay, so I can say the conclusion is the root locus is useful and powerful analysis for higher order system. Slide number 17. So can we draw? The issue is, can we draw a root locus for a higher order system? The answer is yes. Okay. And properties of the root locus will be helpful to sketch a root locus for higher order system by considering a closed loop system with the feedback HS as shown here. Okay. If HS is equal to 1, meaning that there is no sensor, so you just replace this one with 1. Okay. So a pole S exists when the characteristic polynomial becomes 0. Okay. Or by formulation is here. KDSHS equal to -1 equal to 1 angle 2K plus 1. So this one is the magnitude. And this one is the phase. Okay. Phase angle. But K is equal to 0, 1, 2, and so on. So alternatively, we can write it as here, magnitude is equal to KDS, which is equal to 1.
有像都说有像的，有像，他也是也比较尖哦，也真。
Yo, microphone off.
可能下一代，我们就是其他，现在在感觉自己整个变酷了。
Okay, so this is the magnitude. Symbol of magnitude equal to 1, and then the angle is KDSHS 2K plus 1, 180 degrees. Thus, a pole of the closed loop system cause the angle of the KDSHS to be an odd multiple of 180. Okay, odd number lah. 1, 3, 5, and so on. And the magnitude of KDSHS must be unity. Unity is 1. Okay. Thus, the gain K can be calculated as K 1 over GSHS magnitude. Okay, so please remember these three formula. Okay, when we are doing root locus tools. So the root locus concept, by looking at the table just now, okay, from the previous example, closed loop poles exist at S equal to minus 9.47 and minus 0.53 when the gain K equal to 5, okay, which is the second line. So when the value of the open loop KGSHS, which is equal to K over S over S plus 10, by substitute this S inside here, okay, and K equal to 5 inside here, then find the KGSHS, which is equal to 1, or magnitude equal to positive 1. And this closed loop poles must satisfy this requirement. Because when it satisfies the requirement, meaning that this point is located on the root locus plot. So we consider this open loop transfer function shown here. Okay. K S plus 3, S plus 4, S plus 1, S plus 2. Question. Amira Suraya?
Yes, saya.
What is the value of open loop poles from this open loop transfer function?
-3, -4.
Thank you. Ashurizan, what is the value of open loop? Salah ni, open loop pole salah. Open loop, ni open loop apa? Merah Suraya, salah ni. Open loop poles. -1,
-1, -2.
open loop zeros. Baru -3,
-3, -4.
-3, -4. Okay. And this is the unity feedback. Okay. Unity feedback. H is equal to 1. So you are given this point, -2 plus J3. Check whether this point is a closed loop pole of the system or not. Or in another word is check whether is on root locus or not. Or another word lah. Okay. To be a closed loop poles, to make sure that this -2 plus J3 is on the root locus or is a closed loop pole, it must satisfy the requirement of angle and gain criteria. Must be fulfilled. Okay.
Kan tak expect yang kat luar tu pun sekali. Ingatkan Jaya supermarket.
Nurul Alia.
Oh.
Nurul Alia. Nurul Alia. Nurul Alia. So we plot the root locus using the computer. Okay. So how to plot it using the computer? Nurul Alia. The code. Nurul Alia. Tak ada. Tak datang. Nasrul. How to plot?
Ya, Doktor.
How to plot this? By using MATLAB. S equal to?
TF.
Okay. Lepas tu? E equal to? 1 S plus 3 S plus 4. Correct.
Yes.
Saya pula buat. Tolong. S plus 1
S plus 1, S plus 2.
plus 2. Lepas tu locus G. Lepas tu grid. Okay. Lepas tu apa? Lepas tu enter. Lepas tu
Enter.
jadi enter dia keluar macam ni. Okay. So what is this point? Aiza, what is this point? Ali Imran, what is this point? The name of that point? Tak tahu.
Root locus.
Salah. What is the point of this? 0 tu. Apa nama dia? Darren?
Ya, doktor.
Ya, ni. This point, the name.
Zero.
No, 0 mah. Satya.
Origin.
Origin. Origin. What is the name of this line? Lau?
You call me?
Name of this line. Straight line. This one.
Which one?
This
The
one.
horizontal one? Real estate.
Huh?
Real estate.
Oh, later line.
On the
Okay. Lau, what is the name of this line?
Zeta also?
Kita already mah, the straight line. This one is circle. Yong? Oh. Nasrul?
Ya, tu.
Omega N. Okay. Okay, so this is the open loop poles, open loop zeros, -3, -4, open loop poles, -2, and -1. So the root locus start from the poles ended at zeros. Okay, so if we look at the green line, okay, the green line start from here, okay, start from here, and then this one, blue line, start from here, start from here, and then there is a, what do you call, what is this? The name of that point.
Breakaway point.
Breakaway point. So the green line will go down. Okay, the path go down, and the blue line will go up. And both of them will meet again here. What is this point? The name of this point? Break-in point. Okay, just now is a breakaway point. Okay, so breakaway point, the point is met and then split. But this one, break-in point, then met and go inside. Okay, look at the arrow. Then this one will end at 0, and the green one will end at minus 4. Okay. So we check whether minus 2 plus J3, is it this point is closed loop poles or not? Is it this point is on the root locus or not? Okay, by using the angle of criteria. So we assume the point is here, minus 2 plus J3. Okay, so we measure the angle. Okay, so how we measure the angle in this diagram? Izhar, how we measure the angle? Theta 1, theta 2, theta 3, theta 4. Using what? Tak datang.
Formula just now.
Ha? Yalah, apa benda dia? Formula tu apa benda?
Oh, formula dia ke?
Dapat formula, bagi detail sikit lah.
2K plus 1
Ha.
bracket 180 degree. Is it?
No.
Oh, bukan eh.
How to measure theta 1, theta 2, theta 3, theta 4 from this figure? Guru Najihah. Cepat lah. Kamu.
Trigonometry.
Ha? Trigonometry. Okay, what is the trigonometry? Let's start with theta 1 first. Let's start with theta 1 first. Okay. Dia punya height dia adalah 3. And then dia punya bawah dia tu adalah 2. So, Guru Najihah? Apa? Guru Najihah. Degree, what is the degree? 50. Guys?
Yes, Prof.
56.31. Correct.
Yeah.
Don't sleep in my class. Face to face, you come and see me. I will catch you. Okay, theta 2. Theta 2 equal to? Samuel?
Yes, Prof.
Arctangent.
Yes, Prof.
Arctangent.
Just a minute. I
71.57 degrees.
How much?
71.57.
Thank you. 71.57.
57.
Then theta 3. Theta 3.
90 degrees.
90 degrees, but according to the formula, is some angle of zeros multiplied by some angle of poles. So poles is downstairs, so minus this is one is 90, so it is 90 degrees. And for theta 4, you have to use this is theta 4. Can this one is 1. Can this is 1, this is 3. So let this one be alpha. So alpha is equal to tangent. How much?
71.57.
71.57 again. So theta 4 is 180
Minus
multiplied
alpha.
minus 57.
108.43.
Yeah, 71.57. Repeat again.
108.43.
43 degrees. Okay. So this value will enter to the formula as negative because its poles will give a negative angle. 0 will give the positive angle. Okay, so total up is minus 70.55, which is not equal to 180. Okay, so not fulfill angle criteria. So if not fulfilled, meaning that minus 2 plus J3 is not on the root locus, right? Then we choose another point, new point. Minus 2 plus J square root 2 over 2. This one is minus 2 plus J 0.707. Okay. Right. So by using computer, we can make sure that this minus 2 plus J 0.707 is on the root locus. Okay. There. Point there. Okay. Okay. It's located here. Okay. So we use the formula here. Again, we repeat the trigonometry. Okay. But this time around, theta 1, theta 2, theta 3, theta 4. Repeat again as just now. And then you can see that it will give you 180 angle criteria is equal to 180 degrees, which is satisfied angle criteria. And then we calculate the K, the gain, 1 over GSHS using the formula. Okay, then you will get 0.33. Okay, so that's minus 2 plus J 0.707 is on the root locus. This one proved by the simulations. Say the gain there 0.33 and it is a pole closed loop poles is minus 2 plus J 0.707. Or simply you can check using a MATLAB. You write a program, syntax program. This one is not on the root locus. This one is on the root locus. Okay, using the code that I show here. G is the transfer function, theta is the angle criteria, M is the magnitude, and K is the gain. Okay. This is the angle. Okay. So we check this theta is not equal 180 degrees, but this one is equal to 180 degrees. So 179.9993. Okay, more or less approximation, substantially 180 degrees. Okay, so I remind again all the formulas for the magnitude, for the transfer function, for the angle C. You see there? Summation of angle of zeros minus summation of angle of poles. Okay. So we stop here. Any question? Any question, guys?
No questions so far.
Huh? No
Oh,
question.
wait, I may have a question.
Yeah, please. Yeah,
Excuse me.
yeah, sure.
Yeah, it's actually pertaining to, excuse me,
Yeah.
section pula. Slide 14.
Slide 14.
Yeah.
Oh,
Yes, this slide.
uh,
I'd like to ask, how do we know that the region, the above quadrants are the under dam zone?
how do we know?
Yeah, how do we determine how do we know that the above quadrants are the under dam zone?
So you have a S-plane. Okay. Okay. This one is a right half plane. Am I right? This one is
Yes.
left half plane. This is the origin. Okay. So of course, we will not go here because this is unstable region. Am I right?
Mhm.
And the stable region is on this side. Am I right?
Yeah.
So we make sure that since we have these two, the top one and the bottom one, so we always refer at the positive one. Okay. For the analysis because it's the same. So we choose this one instead of the negative one. Am I right? So we choose this one. Okay. This one is negative, so we use the positive side. Okay. And at this level, at this axis, the zeta is equal to 0. At this axis, zeta is equal to 1. And
Oh, okay.
and this region, the zeta is between 0 and 1. So you must make sure that it is on this quadrant. Okay, guys?
Okay.
I try to generate the tangents, but it's very slow, this line. Don't know, maybe because of raining. So we can wait for a while. It's still, searching for the class attendance. Okay. Any question? Izha? Any question?
So far, don't have, Doctor.
You don't have question, eh? Dini, any question?
No, sir. If I do have, I'll text you later. I'll email you later.
Budak baru nak masuk. Kita tanya dia dulu. Dini, apa beza, what is the difference between breakaway point and break-in point?
From the slide that you showed earlier, the breakaway point is where the I don't know how to say this, but the green line and the blue line separates. The blue line will go up and the green line will go down. And they will meet at the break-in point, where the green line will exit the break-in point to the left, but the blue one gets inside the circle and continues on the real axis towards 0. That's all I know.
Your question is very long. I can't understand. Do you understand? Dini answer. I think it's too long.
Yes.
Nurul Najiha, can you simplify the answer? It's too long. I don't understand.
Breakaway tu,
English.
breakaway diorang jumpa
English.
lepas tu berpecah.
No, speak in English. They don't understand. Speak
Apa?
in English.
Aduh, susah sikit. Uh, they meet at the same point and then they separate the way and break in. They meet at the same point, but they enter the point. Yeah, something lah.
I'm not satisfied with your answer. Let's see can we see what do you call it? Let me see other answer. Can we invite Liu Hong? Liu Hong. Tak datang. So, Juan, Pauli.
Yes, doctor.
What is the difference between break-in and breakaway point?
From my opinion, breakaway point is multiple poles diverge and move apart when K increase. And the break-in point is they merge together when K increase.
Kan? Betul kan? Lim. Lim Lee Sin.
Yes.
Lim tidur ke?
Yes.
What is the difference between break-in and breakaway point?
Um, Breaking.
Can see that breakaway is between two poles. Am I right? Break-in between two zeros. Am I right? That is one difference that I can spot. Okay. Then the directions of the breakaway point is going out, and the direction of the break-in point is going in. Am I right?
Yes.
Okay, long. Can you fill up your attendance? Any question from this one? Is there any question? Have you filled up the attendance?
Yeah.
Okay. Any question? Fill up the attendance and then we can see you next week. Amira Suraya? Amira,
Yes, doctor.
dah isi korang attendance.
Dah.
Yeah. Samuel Bai.
We do have class on Tuesday.
Tuesday? Next Tuesday. Next Tuesday is 25th. Yes, we have a class on the 25th.
Okay, okay, bro. Thank you.
Is there any holiday next week? Is there any holiday next week?
Ada Monday,
One got Monday.
Okay.
birthday Sultan.
You want to
Sultan
celebrate?
Johor.
You want to celebrate? That is, you are not involved because that is section 11 and 12. I will discuss later with them. At the moment, section 7 and 8 is not involved on Monday. Am I right?
Yes, Prof.
Okay, bye. No issue. Okay, thank you very much for your attention and see you next week.
Thank you, sir.
Bye-bye.
Sir,
Yeah.
just I just like to double confirm. So test one is on the 24th of April, right? From 5:30 to 6:30.
24th of April. Yes, yes.
Okay.
6 a.m.
Thank you.
I'm saying. Sure. Bye.
Prof, can I stay? I want to ask something after everyone leave.
8 minute. What is the question?
I wait until everyone leaves.
No, it's okay. WhatsApp lah. I want to go to the toilet.
I mentioned in the WhatsApp then, Prof.
Okay.